Alright, so we're going to use partial fractions to integrate this rational expression over here. I'm going to jump straight into it. The integral of 2x minus 3 over x squared minus 3x minus 4 with respect to x. Now, we want to split this into a partial fraction. That's what we're doing. Now, to do that, our denominator needs to be ax plus b times cx plus d or minus d, whatever it might be. So forget integration for now. We're going to take our expression 2x minus 3 over x squared minus 3x minus 4. Now I'm going to rewrite that as x plus 1, x minus 4. That looks about right. 1x, negative 4x. Yep, that'll work. So now that I've got it in that form, I can say that it's going to be equal to a over, sorry, you should use a capital A there. Capital A, x plus 1, plus capital B, x minus 4. Okay, good so far. Now what we're going to have to do is take our x minus 4 and multiply top and bottom by x minus 4. So it's going to be a times x minus 4 plus b times x plus 1. And all of that is going to be x plus 1, x minus 4. And now we just need to find out what a and b are. So this is really something you've done before. We can say that 2x minus 3 equals a, x minus 4, plus b, x plus 1. Now this probably doesn't really follow, so I'll just do a little equals, because we're forgetting about the denominator entirely, because we know that 2x minus 3 has to equal this. We're equating the numerators. Okay, so now we just need to let x equal positive 4. And let x equal negative 1, and we should be able to solve it for both a and for b. You've done this. Alright, so it looks like b equals 1, and we're also going to have to do the second half of this. Looks like, trying to rush through that, it looks like a is equal to 1 and b is equal to 1. Obviously that's not always going to be the case, but it is the case in this particular question. Now that we know what our a and our b are in our partial fractions, we can rewrite this, and we can say that the integral of 1 over x plus 1 plus 1 over x minus 4. Because we know our a value was 1, and we know our b value was 1 in these, with respect to x. And now we're just going to integrate those fractions individually. 1 over something, that's going to be a log. So we're going to end up with log base e, x plus 1, plus log base e, x minus 4, plus the c. And it's important that you look at this one, and you're going to have to do this a lot. You're going to have to look at this and decide on the bounds for this. So remember, this has to be positive, and this has to be positive. Both of these have to be positive. You can't have a negative inside of a log. So how can we prevent ourselves from having a negative? Just check negative. I'll just do it down here. Check negative. Alright. Now here, x needs to be greater than negative 1. As long as x is greater than negative 1, then we're good. X needs to be greater than negative 1. But here, x needs to be greater than 4. Or x needs to be greater than 4. So if we look at those two, x is greater than negative 1 or x is greater than 4, this one kind of overpowers this one. Okay, so we need x to be greater than 4. Just put it in brackets here. X greater than 4. This only works in that instance. Otherwise, there's no integral. Now, you do just want to simplify this. This happens a lot in partial fractions. You do want to look at this. This is log base e of to something plus log base e something. We can rewrite that as log base e x plus 1 x minus 4 plus c. So we're just multiplying those two using our log laws. And we can write that now as its expanded form, perhaps, which is the same as that there. Log base e x squared minus 3x minus 4 plus c, where x is greater than 4. Where x is greater than 4. Partial fractions, a little bit to do there.